good evening. Welcome to my YouTube channel. Last time we have discussed our first topic of plus one units and measurement. So in this chapter we are going to study about the dimensions. I have told you how to write the dimension of any physical quantity. Let's start with some of the example. Here I am going to take the example of a very important physical quantity, which is work. As we all know, what is work? Which is force into displacement. And if I want to find the dimension of force, so as we all know, according to Newton's second law, force is nothing but mass into acceleration. So this formula is already we know, because this is the second law of motion. And the dimension of m is what? m1. The dimension of acceleration is what? How to find the dimension of acceleration? As we all know, the acceleration is what? Velocity upon time. So here I am going to write the dimension of velocity, which is Lt minus 1, because velocity is equal to displacement upon time. And what are the dimension of displacement, which is length? And what are the dimension of t, which is p? So Lt minus 1. So here I have put the value of velocity over there. So now in a denominator we have t. So this t will go into the numerator. That power become add each other, which is Lt minus 2. So simply I am going to put the value of acceleration Lt minus 2. So I have find the dimension of force. So basically here we have find the dimension of a very basic physical quantity, which is force, and this is the derived quantity also. So there are many physical quantities in this chapter that we are going to discuss. So simply by using these simple dimension, you can calculate the dimension of any physical quantity. Let's take another example, which is what? Work. And work is also considered as energy. So in this we are going to take work and energy. Both are similar thing. When you are going to find the dimension of work, which is same as that of energy. So as we all know, there are many kind of energy, but to discuss, first we have kinetic energy. And you know what is kinetic energy, which is half of mv square. So guys, half, 3, 4, any value which is a arithmetic, or we can say any natural number, any whole number, any integer. So this has no units, because this value is always dimensionless. So this thing you remember, guys. So we have to calculate the dimension of those quantity that we can measure. For example, mass, for example, length, for example, time. So these variables we can calculate the dimension. So simply here we have mass, so I am going to write m1. So here we have v, and you know velocity. Velocity, the dimension of velocity, which is nothing but Lt minus 1. So simply I am going to do the square of this particular thing. So after going to do the square, ml square t minus 2. So here I am going to find the dimension of kinetic energy. So whenever you see a energy, either it would be a kinetic energy, either it would be a potential energy. So simply energy has same unit as work. So how to find the dimension of this particular quantity? Let's take last example, which is very important. I am going to take the dimension of momentum. So guys, what is momentum? So guys, what is momentum? So let's say I have a duster, I have a marker. So which thing has more momentum? So if you see the weight of this duster, or we can say this marker, the weight of duster is more than this marker. So the momentum of this duster is more than that of this marker. So what is momentum? The mass of the object. What is v? Velocity of the object. What is the formula of momentum? Mass into velocity. So simply if I want to find the dimension of this particular thing, mass has m1, velocity has Lt minus. So simply we can calculate the dimension of a momentum.